So hi guys, today we'll be starting a new chapter which is straight lines. There are formulas. This is a small chapter, not very big, and formulas are also not more, just 20, 25. So let's recap it. Have a quick revision of all the formulas. So you already know this excellent formula. I think you are already studied it in 10th. Like this is the line with the chord with the x1 x2 points, and it's dividing it into ratio lambda is to 1. Then we get this point ratio this. If it is lambda is greater than 0, that means it is dividing it internally, and if it is less than 0, lambda is less than 0, that means it's dividing externally. What do you mean by externally is the point will not lie between that. For internally, the point will lie on the line, otherwise it will lie somewhere outside the line, like here, somewhere here. Okay, the centroid of the triangle with the vertices, and I hope you know what is a centroid. Centroid is basically a triangle. The median of the triangle, suppose these are the two, all the midpoints, then these are the midpoints, where they join, this is called the centroid. And to get the point centroid, that is x1 plus x2 plus x3 upon 3, where this is x1 y x2 y2 x3 y3, this is how you get the point. Just add all the x values divided by 3, add all y, and to get the y coordinates. The incenter of the triangle ABC with the vertices, this, what do you mean by incenter is, suppose this is the triangle, putting altitude here, altitude, and here an altitude, then the point where it meets is called the incenter, and this is given by this. Suppose the triangle was ABC, where BC is this line, x1 is this one, x2 y2, and x3 y3. This is how we get. Then we get the equation, that is x1 into BC, x2 into CA, and x3 into AB. There's the opposite sign from that point. This is x2, then the opposite side. You know that you have to multiply it, then all the add of all the lines, sum of the lines. Then you get x-axis. Similarly, you get y-axis. It's easy. I hope you already know. So the x-centers of the ascribed circle opposite to the vertices A, B, C are this. I hope you know what are x-centers. Suppose this is the triangle, then when you you just have to do this, then you make a circle out of here. Something like this. Something like this. Okay, so on the sides you make triangle touching the tangent, which is the side here as it is. That's this is called x center, and the center of this is called x center, and this is called x circle. The centers of the scribed circles opposite to the vertices A, B, and C. Yeah, this is A, this is B, this is C. The opposite to one this, opposite to one this, and opposite to one is this. So how you get the x centers of this? The centers of we can get by using the formula this minus b. What is x1? Suppose this is x1 y1, x2 y2, x3 y3. This is similar, right? Then you minus b. Suppose you have to put one thing minus, like it is here we have taken minus as the b, here we've taken minus c. I'm telling you the way to learn it. Here we take in a as minus. So that's why rest all the formula is the same we used to find the incenter. The just we studied before this. I hope you know now. Straight lines. Every you learn it also now, because I'm telling you the trick to learn these equations also. Straight lines. Every equation of the first degree in x and y always represents a straight line. Every equation of first degree, x and y always represents a straight line. Whenever you have x and y in any equation and x and y are the first degree, then it will always represent a straight circle, a straight line, sorry. The equation of the straight line passing through x1, y1 and making an angle theta with the positive direction of x-axis can be written parametrically as this. This is how we can, we know how to, like these are the parametric form, to get the equation of the line, and if you have been given angle and you're given x or x1, suppose this is the x1 y1, then you can easily get the point x. So this is x. Okay, so you can easily get it by using this formula, the equation placed. If you put the value of x1, you put the value of theta, you'll get the equation of the line. Very simple. And distance you can also get. This is the like x1 plus r. Suppose this was the one that we're talking about, like r. R is this point, the point on this distance, r to this distance. It's very simple. So yeah, you can get it using this formula, x1 plus r cos theta plus y1 plus minus r sin theta. That's how you see, how you get the distance. And any point on the distance r can be represented like this. This is the simple parametric form. I hope you have studied it. If you have studied it, you know, because lots of questions have solved using this. If you have theta, then you use this formula. But if you have not been given theta, but only the 2 points, then you get this, then you use this formula, that is y minus y1 is equals to y1 minus y2 upon x1 minus x2, x minus x1. This is simply the slope, you know, y1 minus y2 upon x1 minus x2, y2 minus y, x1 minus x. Those slope will always be equal, right? If you've been given on a line, you've been given 2 points and you asked about the slope. It's very simple. The equation of the line can be found. If you're given 2 lines, then this is how you find the equation of that line. Suppose now the third way, not the third but the fourth. 2 lines a1x plus b1y plus c1 is equals to 0 and a2x, these the 2 lines are given. Then how to, like if you've been asked whether they are parallel or not, then this is the condition. a1 upon a2 is equals to b1 upon b2 is never equal to c1 upon c2. And if the lines are coincident, then this is the equation. Then this is the condition that it should follow. That is a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. And if the 2 lines are perpendicular, then they will follow this condition. a1 a2 plus b1 b2 is equals to 0. And if they are intersecting at any point, then you will see that it will follow this condition. a1 upon a2 is never equal to b1 upon b2. That's it. And the length of the perpendicular drawn from x1 to the straight line, suppose this is the straight line, this is x1 y1 and you're drawing a perpendicular on it, then yeah, then the length of this line L can be used using this. Suppose this is the x1 point and this is the line's equation, then you simply write it in this form and then you get the L. Very simple. So it can also be in the form like distance between a point and the line. This is in 2 parallel lines. Suppose we have given 2 parallel lines and we have to find the distance now, the L. Yeah, so this and this are the 2 lines. Then you simply can find L using this formula, that is C1 minus C2 upon C1 and C1 are the constants. This C and C1, just have to put the values and then under root a square plus b square and you get the value of L. Simple. The equation of the straight line passing through the point of intersection of the 2 given lines, L1 is equals to 0 and L2 is equals to 0, may be written as, suppose this is this first line, this is the second line, this is only in the like L is equals to 0, L2 is equals to 0, this is same. You didn't get me. Sorry, you didn't get it. The equation is the straight lines. That was I was telling you about. So now, just look at it. Okay, it's simple. I was telling about this one and I forget to give it. Now we're talking about the, because you already know this is already you have studied in 10th also and right now just I've explained. So the 6th one is L1 plus K L2 is equals to 0. This is the equation for the family of lines. 2 lines have been given and they are passing or to each other, passing through the point of intersection. That means there is a point of intersection like this. Then you can use this equation to get the equation of the lines. That the equation you get after putting in this, then that will be the equation of both the lines. That one equation can be represent the both lines. So now the relative position of the points x1, y1 and x2, y2 with respect to the line ax plus by plus c is equals to 0. Suppose this is the line, right? That we're saying. And x1 and y1 and x2 and y2 are on this side of the line. And they are on the next, if it is on this side of the line, then it will be positive. It can be negative. Then if this is positive, then this will be negative. It means that if it is this side is positive, then this side will be negative. If this is positive, then that will be negative. It just means that. See, in the same side, if they are on the same side, they both will have the same sign. But if they are on the opposite sign, x2 and x2 and y2 are on this side, then they will have negative signs. They have different signs. That's what I'm saying. If they are on the same, suppose this is x2 and y2 is on this side, then they will have the same sign. But if x2 and y2 is on this side and not here, then they will have different signs. That's what it means. Like the same side of the opposite side of the lines according this at the same sign. That's what I'm saying. The equation of bisector of the angles between the lines a1x plus b1y plus c1 is equals to 0. And suppose this is one line and this is the another line. Then and you have to find the angle bisector. This is the line, this is the line. You have to find the angle bisectors line. Then to find the bisector of the angle, actually there can be two lines bisecting them, right? One can be this, another can be this. This line is also bisecting the two lines, and this line is also like this line is also bisecting. And one more line was there, that is something yeah, basically there will be two lines. Not this way. Suppose these are the two lines, then you can have one angle bisector, this is bisecting them, and you can also have this angle bisector. So you can see now you have two angle bisectors. That's why it is plus and minus. You will get two equations from here, and both the equations, one equation will be for this line and another equation will be for this line. I hope you get it. The foot of the perpendicular this to the straight line, this is given by this. So this is the straight line ax plus by plus c is equals to 0, and foot of the perpendicular is alpha beta from some point x1 and y1. So if like you have been given the equation of the line, you have been given this, then you can easily find this equation. This is the way. This is the very simple equation. By putting the values, you can find the value of alpha beta. You can, if you have alpha beta and you are missing this, then you can find the value of this. Basically the foot of the perpendicular, to find foot of the perpendicular is alpha and beta. This is the foot of the perpendicular, because perpendicular is lying here. This is the foot of the perpendicular, and to find this foot of the perpendicular, you have to find the alpha and the beta. From alpha you will get from this equation, and beta after equating these two equations, and alpha after equating these two equations. That's what I'm saying. I hope you get it. Image of the reflection of the point x1 and y2 in the line ax plus by plus c is equals to 0 is alpha beta. Okay, image of the reflection, you getting it? This is the line, this is the point, and the reflection of this point will be somewhere here. And to find the reflection of the point is called the image of the point. This is alpha beta, and this is x1 y1. Then to find this alpha beta, you have to use this equation. The only difference is this, it is twice. Why? Because plus 1 plus this. That's why. Here it was once, here it becomes twice. That's what the difference is. That other than that, everything is same. If you remember this equation, you'll easily be able to remember this equation. Both are very same. So the next very now we reach to area. So area, the area of the triangle formed by this line, and this line can be represented using this square units. Very simple. It's mod, because area can never be negative, you all know. So 1 upon 2, then if one c1 and c2, then the other c2 c3, like that. So you have to find the sum of it, and then you get this formula. Area of the triangle can formed by the line this with the coordinate axis. Suppose it was the area of the triangle. This is this line, this is this line, this is this line. Then you use this formula. But if you have coordinates, that is x-axis and y-axis, and you have a line ax plus by plus c, and you have to find its area, then it's very simple, because it's coordinate only. You don't have any other two lines, but the coordinates are the lines now, the triangle. So you'll have this formula. It's very simple. AB is nothing but the coefficients of x and coefficient of y. Very simple. Remember, this formula is very great. Then the area of the rhombus formed by this. For rhombus, you will have four lines, right? Suppose this is the rhombus that we are talking about. One will be ax plus by plus c. Other will be ax plus by minus c. And this line will be ax minus by plus c and ax minus by minus c. So you got the four equations, and to find the area of this rhombus, this is the equation. This is simply applied to c square upon ab, and you'll get the area of the rhombus. It was c square for the triangle, and for the rhombus it's just 2, so you can remember it. If you remember this, you'll easily remember this. Now the area of the parallelogram for the lines. Now we have a parallelogram. These two lines are parallel and these two lines are parallel in parallelogram. So if this is the A1, this line, this is this line, this is this line, this is this line, then you can find the area by using this formula, that is C2 minus C1. That is C2 minus C1 D2 minus D1 upon A1 B1 minus A2 B1. And it's simple. This is so simple, and here where the chapter ends. Simple. And you are just taught to find the area, and this equation came from the determinant. You would have studied that in NCERT. It's same. So here we are ending. Thank you.